This is the Triangle Inequalities tutorial. An important aspect of triangle inequalities is that when comparing any two sides of a triangle, the side that is the longer of the two will always be opposite from the angle that is the larger of the two angles. In order to illustrate that, let me bring in triangle QRS. And I'm going to label the sides of triangle QRS as having a length of 9 for QR, a length of 7 for RS, and a length of 15 for QS. Now, if I were to compare two sides of the triangle, so in this case I'm going to compare side QR to side RS, and I know that QR is longer than side RS, because QR has a length of 9, while RS has a length of 7. Now, according to the statement on the right, the angle that is opposite QR must be greater than the opposite angle of RS, because QR has a greater length of RS. Well, the angle opposite segment QR is 45 degrees, while the angle opposite RS, 35 degrees. So, the next thing we want to say about these triangles is that when comparing any two angles of a triangle, the angle that is larger of the two will always be opposite from the side that is longer of the two sides. So what I mean by this is, let's compare angle Q to angle S. So we're going to compare angle Q to angle S. We know that angle Q is less than angle S, because angle Q is 35 degrees, and the measure of angle S is 45 degrees. Now, according to what we just said, the side opposite the larger angle is going to be greater than the side opposite the smaller angle. Well, the side opposite angle Q has a length of 7, and that is smaller than the side opposite angle S, which has a length of 9. So that statement is also true. That's going to lead us into the triangle inequalities theorem, which states that the sum of the two lengths of any two sides of any triangle will always be greater than the measure of the third side of that triangle. I've drawn a couple pieces of information here to help us out. This is a summary of triangle QRS to the left, which obeys the triangle inequality theorem. Let's work it out together. I've said that segment QR is less than the sum of segment RS plus QS. Well, segment QR has a length of 9, which is less than RS, 7, plus QS, 15, because 7 plus 15 is 22, and 9 is less than 22. The second piece of information that follows the triangle inequality theorem is that segment RS, which has a length of 7, is less than segment QR, which has a length of 9, plus segment QS, which has a length of 15. The sum of 9 and 15 is 24, which is definitely greater than 7. And the last piece of information from the triangle inequality theorem is that segment QS, which has a length of 15, is less than the sum of segment QR, which is 9, and RS, which is 7. 9 plus 7 is 16, which is greater than 15. Triangle QRS obeys the triangle inequality theorem because it's a correctly drawn triangle. Let's go over an example of a triangle that is not correctly drawn and does not obey the triangle inequality theorem. What if segment QS was not actually 15, but according to our problem, it was 17? Would that still obey the triangle inequalities theorem? Well, let's check. According to the triangle inequality theorem, segment QS, this side of the triangle, would have to be less than the sum of the other two sides of the triangle. So, QR plus RS. Let's check and see if it is. Segment QS has a length of 17. while segment QR has a length of 9, and segment RS has a length of 7. Well, 9 plus 7 is 16, and 17 is not less than 16. So this triangle can't actually exist because of the triangle inequality theorem, which tells us what kind of triangles can exist based on the side length measurements and the angle measurements.